the SDK Manager. If you already have a project open, you get to that from Tools. In the SDK Manager, click on SDK Tools and look down here to make sure that the Intel x86 Emulator Accelerator or the Haxum installer is installed. If you see an option to upgrade, do so. Now, go to your SDK directory. On my system, I've installed the SDK under my library directory, under my home directory, and under there, I find Android and then SDK. From there, go to a directory named Extras, and you should see a directory named Intel, and under that, the directory containing the Haxum installer. On Mac, you'll find a DMG file, and on Windows, an executable. To a directory Android library, go to your SDK directory. On my system, I've installed the SDK under my library directory, under my home directory, and under there, I find Android and then SDK. From there, go to a directory named Extras, and you should see a directory named Intel, and under that, the directory containing the Haxum installer. On Mac, you'll find a DMG file, and on Windows, an executable. On Mac, I'll open up the DMG file, and then I'll run the installer from here. If you've already installed Haxum, as it's likely you have during the Android Studio installation, you'll see this message indicating that it's already installed. But that's fine. You can just continue the installation. And now you'll be overriding the existing installation. If you see a security prompt, fill out the dialog and continue. In the most recent versions of this installer, there aren't any options. In the past, you indicated how much memory you wanted to allocate to the Haxum process. But now that's all handled dynamically. So all you have to do is install the software. And when this process is complete, you'll be ready to run virtual devices on the Android emulator, and they'll be as fast as they can be on your development system. After installing the Intel Haxum software, you're ready to create and use virtual devices. You can get to the Virtual Device dialog from the Welcome screen by clicking Configure and then AVD Manager. Or if you have an application already open, you can go to the menu and choose Tools and then AVD Manager. And either way, you'll end up in this dialog. If you already have virtual devices created, you'll see them listed here, but otherwise just click on Create Virtual Device. Each virtual device has a hardware profile and a system image. The hardware profile determines the size and pixel density of the screen you're looking at, and the system image determines the version of Android. There are many categories here, one for phone and one for tablet, but there are also devices available for Wear OS, that's watches, TV for Android TV, and automotive for Android Auto. I'm going to be creating a simple phone device, and I can choose from one of these many hardware profiles. There are pre-built profiles for standard Google devices, Pixels and Nexuses, but there are also more generic profiles available, and you can create your own hardware profile if you like. I'm going to choose the Pixel 3a, and notice that this is a profile that includes the Google Play Store. This will allow me to log into the Play Store and download apps just as though I were on a real phone. I'll select that and click Next, and now I need to choose my Android version. On the Recommended tab, there are listings for various versions of Android, and notice that all of these include Google Play functionality. but you can also choose system images that don't have Google Play, and there are many others over here. If the particular version of Android isn't already downloaded, you can download the system image from this screen. I'll choose Android 10 or Q and go to the next screen. Now I assign my virtual device a name, and there are other settings down here after clicking on the Advanced Settings button. You can control camera and network functionality, whether the device will use Quick Boot, that means it will save and restore its state upon closing and restarting. You can indicate how much memory you're allocating and set other options as well. I'll click Finish to create the new device, and then I'll click on this button to launch the device time. While the device is launching in the background, I'll show you that there's a menu here that lets you duplicate, wipe data, cold boot, show on disk or view the details of a device, and of course you can always delete a virtual device if you don't need it anymore. When the virtual device starts up for the first time, it should show up now in your user interface on this pull-down menu indicating which devices are connected to your computer. And this now becomes just one of the devices you can use to test your Android app. To test your applications on a physical device, you have to connect your device to your development computer. You can do this with either a wired or a wireless connection. I'm going to focus on how to work with a device that's connected to the computer using a USB cable. If you're working on Windows or Linux, you might need a device driver. Once you've created a virtual device or connected a physical device to your development computer, you can run your application. You can see your list of available devices in this pull-down menu, and notice that I have a virtual device that emulates the Pixel 3a and a physical device, an original Google Pixel. If you don't see the toolbar in this position, you can go to the menu and choose View, Appearance, and then Toolbar. Now I'll click this button to run the app on the selected device. At the bottom of the screen you'll see a message saying Gradle build running, and then an installing message. And then the app should be launched on your device. And then the app should be launched. At the bottom of the screen, you'll see a message saying Gradle build running. And then an installing message. And then the app should be launched on your device. The first time you build an application, particularly after upgrading to new components, this process of building and launching might take a bit longer. Just be patient, because sometimes new components need to be downloaded and integrated into your build system. Android Studio handles that automatically in the background. Now, I want to run the same application on a physical device. I'll switch to my Google Pixel. I'll click the Stop button up here to stop the app on all connected devices, and I'll run the app again. And this is my Google Pixel running exactly the same application. I'll touch the back button, and that returns me to the launcher screen. It's also possible to run the app on more than one device at a time. Go to the menu and choose Run on Multiple Devices. Choose the devices you want to run on, click Run, and then you should see the application appear on both devices. Here's my Pixel, and here's my virtual device. You can connect as many devices as you like and run the application at the same time on all of them. This building and running process is managed in something called a run configuration. You can edit your configurations by going to the menu and choosing Run and then Edit Configurations. The configuration includes the choice of which module is going to run, what activity is going to be launched initially, and other options. For the most part, you can depend on the run configurations that are created automatically in Android Studio. But you can learn more about the available options in run configurations in the Android Studio documentation. Android Studio has complete integration with Git and the use of GitHub to store your code repositories. This chapter has been completely redone with the introduction of Android Studio 4.1 because there are changes to the user interface when you're working with Git and GitHub. The first step in working with Git and GitHub is to set up a GitHub account. You can go to github.com and click Sign In. GitHub accounts are completely free, and you can store both public and private repositories. Follow through the process of creating the GitHub account, and then come back to Android Studio, and go into Android Studio's Preferences or Settings. Under Version Control, go to GitHub, and set up an account. Now, on my computer, I've already set up the account, so I'm going to verify that I want to use my existing credentials and show that I've already created the account here. If you're doing this from scratch, you can click the plus icon, add your login and your password, and then log in. If you set up two-factor authentication, say with an authenticator app on your cell phone, you'll be able to use that right here from within Android Studio. Now, once you you've created the account and integrated it into Android Studio, uploading an application as a GitHub repository takes just a couple of steps. With the application open, go to the menu and choose VCS, Import into Version Control, Share Project on GitHub. Android Studio will verify that you're authenticated, and then it will ask you for the repository name. The repository name can't have any spaces, so I'm going to eliminate these space characters, and then if you like, you can indicate that the repository is going to be private. I'm going to keep it public for now. The remote value can be left as origin, and the description can be anything you like. I'll leave that blank, and I'll click Share. After a moment, this dialog pops up, asking me to commit my changes. With Git, every commit, that is, every time you save your changes, you have to add a commit message. And this is where you place it. When you create a brand new repository in Android Studio, the default message is initial commit. I'll accept that message and click Add. And down at the bottom of the screen, I see a message indicating that these files are being pushed up to the GitHub repository. When that operation is complete, I see this link. I'll click it, and that opens my repository. Because I didn't say I wanted it to be private,
New MBPR Mold Fighter. It eliminates odors and prevents mold in your aircon.
Burger King 4 Cheese Whopper. Irresistibly cheesy, irresistibly beefy. 99 lang.
Are you having the splash screen when you're trying to capture your display in OBS Studio or Streamlabs OBS? Well, I'm going to show you how to fix it coming up next in this OBS. And this is actually really easy. Shortcut. So if you go to Create Shortcut. And this will create a shortcut on your desktop right now. And now that we have a shortcut on our desktop, go to the right arrow and then go to Integrated Graphics Default. Let's go ahead and select this option right here. And it's going to go ahead and open Streamlabs OBS on your integrated graphics.